draw the shear and moment diagram shown in the figure. So as we can see here, we have this beam with a load of 60 kilonewton and 30 kilonewton. So first thing that we are going to do is to compute for the reaction of the supports. So we have to determine the value of the reaction 1 and the reaction 2. In order for us to solve for the value of the reaction 2, so we have to summate moment at R1. So we have summation of moment at R1 is equal to 0, taking the clockwise rotation as positive. So yung 60 kilonewton will rotate clockwise, that would be positive. So we have here 60 multiplied by the moment arm, that's 2 meters. We have here the R2, it will rotate counterclockwise, so we have here negatives. R2 multiplied by the moment arm, so for this the moment arm is 2 plus 4, so that's 6. And this 30 kilonewton here will rotate clockwise, so it is positive. Multiply with the moment arm, so that's 6 plus 1, so it's 7. This is equal to 0. So computing for the value of the R2, we have here 60 times 2 minus 6x plus 30 times 7. This is equal to 0. Shift solve equals, and we have here 55 kilonewton. So the value of the R2 is 55 kilonewton. Since positive yung lumabas na sagot, meaning the assumption for R2, which is directed upward, is correct. In order for us to compute for the value of R1, so we have to summate force as vertical is equal to 0, taking the upward direction as positive. So we have here R1 directed upward minus 60 minus 30 plus the R2, which is equal to 55 kilonewton. This is equal to 0. So solving for the value of R1, then we have here R1, so that's x, minus 60 and 30, so that's 90, plus 55. This is equal to 0. Shift solve equals, and we have here 35 kilonewton. Since positively lumabas na sagot, meaning the assumption for R1, which is directed upward, is correct. So since we already know the value of the R2 and the R1, then let's proceed to the computation. So first thing na gagawin natin dito is to make use of the shear and moment function. So in the next video that I am going to do is we are going to solve this problem using the area method. So in order for us to make use of the shear and moment function, the first thing that we are going to do is to name each point in order for us to determine the segments. So this would be the point A, and the point B is located at the location of the point A, and we have our point C at the reaction 2 and the point B at the load 30 kilonewton. So for the segment AB, ay ikakat natin siya between A and B. So we would have this. R1, which is equal to 35 kilonewton, and we assume that this distance here is x, and of course we have here the shear, and we have the moment. So for the segment AB, this is the limit of 0 to 2 meters. So for the shear equation, we have here shear is equal to, so as you can see here, yung shear lang na yung mag-create lang ng shear dito is the 35 kilonewton reaction. So this is equal to 35. And this is the equation for the shear. So since we have here, so if we are going to determine the shear at x is equal to 0, so the shear at 0 is equal to 35 kilonewton. And since our limit runs from 0 to 2, so at x is equal to 2, the shear at 2 is also equal to 35 kilonewton. As you can see here, we have this equation. The shear is equal to 35. Now for the moment, we have here the moment is equal to, so that's 35 multiplied by the x. So take note that in determining the equation for the moment, we are summating moment here at the section. So that's 35, it will rotate clockwise, so it's positive. So 35 multiplied by the distance x. Now at x is equal to 0, so the moment at 0 is equal to 0. So what we are going to do is just to substitute the value of 0 here at our moment equation. So at x is equal to 2, the moment at 2 is equal to 35 times 2, so that's 70. And the unit is kilonewton meter. Now, if we are going to recall the idea that the moment is just the integral of the shear equation, and of course, if we are going to take the differential of the moment equation, that will give us the shear equation. So, if we are going to take a look here, so we have here the shear is equal to 35. So if we are going to take the integral of this, then we would have the equation of the moment, which is equal to 35x. So if we are going to take the differential of the moment equation, then we have here the shear equation. So in this way, ay pwede nating ma-check whether tumutugma ba yung equation ng moment natin dun sa shear. Now, we have to take note of this kasi if we have here the shear is equal to 35, then if we are going to take the integral of this, so we would have here the moment is equal to the integral of 35, so that would give you 35x. But since we don't have here, and of course we have here plus the arbitrary constant c, or the constant of integration. Now in this case, the constant of integration c is equal to 0, that's why your moment is equal to 35x. But there are some instances, lalo na kapag yung load natin is uniformly distributed or uniformly varying, etong constant c na to ay magkakaroon ng value. So, mas safe pa din na meron kang moment equation and then take the derivative of that at mapapalabas mo yung shear equation. So, in that sense, ay mache-check mo whether tama ba yung shear equation mo galing sa moment equation. So, tuloy natin sa segment BC. For the segment BC, so galing tayo dito sa point B hanggang sa point C. So ano yung magiging limit natin dito? Since si point B is 2 meters from the point A, so magsisimula tayo sa 2 and then mag-i-end tayo dito. Yung total distance natin is 6. So it's 2 plus 4. So our limit here is from 2 up to 6. So, for segment BC ay magkakat tayo somewhere here between point B and C. So, ito yung makikita natin. We have here 35 kilonewton reaction. And at 2 meters, we have here 60 kilonewton load. And if this distance here is distance x, therefore this distance here is x minus 2. And then here, so nandito si shear and si moment. So in order for us to solve for the shear equation, so we have here the shear is equal to, so we have here 35 that is directed upward, so it's positive, minus 60. So we have shear is equal to, that will give us negative 25. So for our limit, since we have here from 2 to 6, so we have here at x is equal to 2, our shear at 2 is equal to negative 25. And at x is equal to 6, our shear at 6 is equal to negative 25 also. Since makikita natin dito, our shear equation is just constant, no? Na negative 25. So meaning the negative 25 would run from x is equal to 2 up to x is equal to 6. And for the moment, so we have here moment is equal to, we are taking the moment here, so we have 35 times x, and that will rotate clockwise, so it's positive. And 60 here will rotate counterclockwise, so we have here minus 60 multiplied by the distance x minus 2. So simplifying this, and we have 35x minus 60x plus 120. So we have here moment is equal to 35 minus 60, that's negative 25x, and we have here plus 120. Now, ito yung sinasabi ko kanina. We have here the shear equation is equal to negative 25. And if we are going to take the integral of this, then we have the moment is equal to negative 25x plus c. Ang kung papansinin natin dito, kung manggagaling tayo sa shear equation, and we are going to take or to check whether tama ba yung moment equation natin, then hindi natin siya ma-check because in here, we have the arbitrary constant c. But if we have here our moment equation, and from the moment equation, we take the derivative, that would give us the equation of the shear, and this is equal to negative 25. So, from the moment equation, check natin whether tama ba yung shear equation natin. So, palaging safe na mag-check from the moment equation, take the derivative, and i-check natin kung tama yung ating shear equation. So, uulitin ko, kasi kung manggagaling tayo sa shear, papuntang moment, we have the arbitrary constant c, and this, the constant of integration in this case is equal to 120, wherein hindi natin siya madidetermine. So, our limit here is from 2 to 6. So, i-check natin yung value at x is equal to 2 and x is equal to 6. Now, using the calculator, i-input lang natin yung equation natin. So, we have negative 25x plus 120. So, at x is equal to 2, so calc 2, and that will give us 70. So, the moment at 2 is equal to 70 kilonewton meter. Of course, in here, we have the unit for the shear na kilonewton. Okay, so at x is equal to 6, so we just have calc 6, and that will give us negative 30. So we have here the moment at 6, negative 30 kilonewton meter. So, ano yung advantage of having, so ito yung sinasabi ko na, the advantage of having the shear in the moment equation kasi we will be able to determine the value of the moment at any point. So, kung gusto natin alamin yung moment natin at x is equal to 3, just calc 3. And kung gusto natin alamin yung moment natin at 4, so just calc 4. or any value, i-enter lang natin dito sa equation natin, then we would have the value of the moment. So next segment natin is the segment CD. So we have here, so for the segment CD, ay ikakat natin siya dito in between point C and D. So meaning, makikita natin dito sa figure natin lahat ng mga nasa left, no, ng segment CD. So we have here R1, which is 35 kilonewton, and at a distance of 2 meters, so we have here 60 kilonewton. And we have here 4 meters, and nandito naman si reaction 2, which is equal to 55 kilonewton. Now, since nandito yung section natin, then this distance here, since we assume that this distance here is x, no? So this distance here is x minus 6. And for this distance, so we have here x minus 2. And of course, dito ay may expose na yung shear. And yung moment. So for the shear, so we have shear is equal to, so we are just summating forces vertical here. So we have 35 upwards, so that's 35 positive, and this 60 here is downward, so minus 60, and 55 here is upwards, plus 55. So we have here, the shear is equal to 35 minus 60 plus 55. And we have here 30 kilonewton. So we have here 30. Now, since we are in segment CD, our limit here is from point C, which is 6 meters from point A. So we have here 6 less than or equal to x less than or equal to 7. So at x is equal to 6, the shear at 6 is equal to 30. So that would be constant from 6 to 7. So at x is equal to 7, still the shear at 7 is equal to 30 kilonewton. Now for the moment, so we just summate moment here at the section. So we have here moment is equal to, so this 35 will create a clockwise rotation. So we have here 35 multiplied by x, and the 60 will rotate counterclockwise, so minus 60 multiplied by x minus 2. 55 here will rotate clockwise, so we have here plus 55 multiplied by the distance of x minus 6. So simplifying this, as you can see, pwede kang mag-refer dun sa previous na equation mo. We have here the 35x minus 60x minus 2. So, ito na rin yun. Actually, ito lang yung nadagdag sa equation. So, ito ay pwede na natin i-simplify. Kukupihin na lang natin yung sa previous na equation natin. So, we have here moment equal to negative 25x plus 120. And this one, so we have plus 55x, and we have here 55 times 6, so we have 330, so minus 330. So simplifying this, and we would have moment is equal to negative 25 plus 55, that will give us 30 x, and 120 minus 330, that is equal to negative 210. So, minus 210. And titingnan natin kung what will be the value of the moment at x is equal to 7. So, what we're going to do is to input the equation. That's 30x minus 210. So, for x is equal to 6, so calc 6, and we have here negative 30. So, the moment at 6 is equal to negative, and we have here negative 30 kilonewton meter. So, at x is equal to 7, we have to calc 7, and we have here the moment is equal to 0. So, the moment at 7 is equal to 0. So, ito yung magiging pang-check natin, no? Dapat at the end, yung moment natin ay mag-0 para mag-close yung ating moment diagram. So, since we already have the values here, what we are going to do is to draw the shearing moment diagram. And so, if we are going to draw the shear and moment diagram, so we have here, so this is our shear diagram, and this is our moment diagram. So this point here is 0 shear, and this point here. And as you can see here, at x is equal to 0, and kung titingnan natin dito, at x is equal to 0, the shear is equal to 35. So, we have here, the shear is equal to 35. And at x is equal to 2, the shear is still 35. And kung titingnan natin yung shear equation natin, it is constant 35 from A to B. So we have here a horizontal line. And for the moment, so we have here our equation, and the moment is equal to 35x. So at x is equal to 0, the moment is equal to 0. So we have 0 here. And at x is equal to 2, the moment is equal to 70. So we have here 70 kilonewton meter. This is equation of a line. So i-connect natin itong point na to and that point by a line. Ayan. So for the segment BC here, we have at x is equal to 2, the shear is negative 25. So dito, we have negative 25, and at x is equal to 6, the shear is still negative 25, because if we are going to go back with our equation, we have here the shear is negative 25 constant. So we have here negative 25, and this is just a horizontal line. And for the moment, at x is equal to 2, the moment is 70. So that's correct. We have 70 here for the point B, or x is equal to 2. And at x is equal to 6, so we have the moment of negative 30. So in here, we have negative 30. So this is equation of a line. So ang gagawin lang natin is to connect this 70 here and the negative 30 by a straight line. For the segment CD, kung titingnan natin dito, at x is equal to 6, we have the moment is equal to 30, at x is equal to 7, still it is 30. So that's constant 30. So at x is equal to 6 at point C, that's 30, and still that's 30 sa point B, which is x is equal to 7. It's constant equation here, so we just have a horizontal line. And kung isi-shade natin to, ito yung ating shear diagram. Now, at this point, so since we have 30 here, itong load na 30 kilonewton, so siya yung magpapasara sa ating shear diagram. So always, no, check, dapat nagsasara yung shear and moment diagram. So in this point, so 0 na yung ating shear. Now, for the moment, at x is equal to 6, so we have negative 30. So yun yung pang-check natin. So dapat nagmamatch yung previous na sagot natin at the same point. Maliban, no, kung merong applied couple dun sa isang point, so affected, hindi siya magmamatch. So in this case, wala ka namang couple na load. So therefore, dapat mag-match siya. And at x is equal to 7, that's 0. And this is just equation of a line. So we just have line here. So kung isi-shade natin to, ito na ngayon yung ating moment diagram. So hindi siya nagtatapos yung shear and moment diagram natin with the drawing, no? So ano yung mga possible questions to follow? The first one is, if we are asked to find, or if we are asked to determine the maximum positive shear, therefore the answer is 35 kN. Pag yung tanong sa atin ay the maximum negative shear, so sagot ay negative 35 kN. So pag tinanong tayo ng maximum na positive moment, the answer is 70 kN, and the maximum negative moment, that's negative 30 kN. And of course, para ma-determine din natin whether asan ba yung location ng maximum moment natin, kung nasaan yung mga zero shear natin, doon natin makikita yung maximum moment. Now, another question na pwedeng itanong sa atin is, what is the value or what is the location of the point of inflection? So that's x, no? So in order for us to find this value of x here, ay pwede natin siyang gamitan ng ratio and proportion. So we know that this is equal to 2, and so pangalanan lang natin ito na x sub 1. This x here is 2 plus x sub 1. And of course, alam natin that segment BC is 4, so meaning this segment here is 4 minus x sub 1. So, ang gagamitin natin, similarity of triangle lang, itong triangle na to, no? Itong triangle na to at itong triangle na to. So, by ratio and proportion, we have x sub 1 is to 70. Hindi natin kino-consider yung sign pag tayo ay nag-ratio and proportion. So, solving for the value of x sub 1, then we have here x over 70. This is equal to 4 minus x over 30. Shift, solve, equals, and we have here 2.8. So this is 2.8. So para makuha natin yung value ng x, that is x sub 1 plus 2, so 2.8 plus 2, the value of x here is 4.8 meters from the point A. So ito yung sagot natin na location ng zero moment or the point of inflection. Now, if we go back, no, we have here the zero moment at the segment BC. So ibig sabihin, kung babalikan natin yung moment equation natin, we have here moment is equal to negative 25 plus 120. So parang since yung zero moment natin can be found at segment BC, so yung moment ng BC yung gagamitin natin in order for us to determine this value of x here. So we have the moment is equal to negative 25 x plus 120. So para malaman natin kung ano yung value ng x, we know that, so dito hinahanap natin yung zero moment, so we let moment is equal to 0 in order for us to find the value of x. So solving for the value of x, so we have here 120 divided by 25, and that is equal to 4.8, and x is equal to 4.8 meters. wherein ito rin yung na-compute natin kanina gamit yung ratio and proportion. So, dito natin makikita na malaki yung tulong ng shear and moment equation para mag-compute ng mga values na hinahanap sa atin. So, abangan nyo yung next video natin. Gagamit naman ako ng area method para ma-drawing natin yung shear and moment diagram.